Hello everybody, we're still talking about the continuity equation, and in this video we will be discussing one important topic, which is the information that we need to know so that we can solve these equations. And this is a very important point to know what are the information that you need so that you get prepared, you know what you need to know, and to gather this information or collect this information so that you can go ahead and start. So the first point, which is a very important point, is to have a very good understanding of your problem, because this understanding is the basis on which you can translate the actual process taking place into the equation. For instance, if you have a steady state, you can translate this into the cancellation of the time dependence term in the equation, but this is based on your understanding. So if the system is not in actual steady state and you assume it's steady state, then you are solving another problem. So you must have a good understanding of your problem with all the conditions and everything taking place in there, and a good understanding of the equation itself, so you can tell what's taking place here is translated into what in the equation. And the only channel that can do this effectively is your understanding. So that's why it's important for you to have this understanding for the equation and for the solution itself, as we will see in the coming video. So this is the first point. The second information that you have to know is what we call the boundary conditions and the initial conditions. So what are these initial and boundary conditions? To get this or understand what they mean, we will check a very simple example. So let's say we have this equation and we need to solve it, and this is a pretty simple equation. Anybody who's learning integration and differentiation will be able to solve it, and it's a very simple, straightforward. You will add 1 to the power and divide by the new power. So this is going to be x power 3 divided by 3. This is negative 1 over y. It's very simple, nothing difficult. But here we will add a constant, and this is what we call the constant of integration. This is because this is a result of the differentiation of this equation. The constant is equals to 0 after it's differentiated. So when we go the other way, we put this constant. So this is the constant of integration. This constant of integration is part of the equation, and we need to know how much, what is the value of this constant. And the way we can do this is by substituting in the equation with an information that we know. So let's say I know that for x equals 1, y equals 5, for instance. So if I substitute here with x equals 1, y equals 5, I can get the value of c. And this is gonna be the value of c that I'm looking for. I put it in the equation, then the equation is fully defined. So I can apply the equation for any value of x and get the value of y, and then the equation is done. So this is what we call a condition. So this is not the boundary condition, but this is just a condition that I know that I can use to get the constant of integration. The if this is a space related constant, so if I say for instance at distance equals x, y equals whatever, then this is called a boundary condition, assuming that x is space or a dimension or something. So let's take another example for this same problem, but I have double integral instead of single integral. So if I do the integration, I'll do it twice. So the first is the same as what we did before. The second is going to be like this. But here I have two constants, one from the first integral, one from the second integral. And then I must know two information. So I know value of x and the corresponding value of y, and another value of x and the other corresponding value of y. So that I have two equations and two unknowns, because I have two variables, so I must know two information to be able to get the values of c1 and c2. So from this we can conclude that the number of constants equals the order of differentiation or the order of differential term that I have, which is a second order integral from here, or differential from here. and the number of information that I need to know, the number of conditions that I need to know, are equal to, it's not boundary condition, it's number of conditions, I'm sorry. So the number of conditions equals to the order of integration or differentiation, whatever. Okay, so if we go back to the previous slide, we said that we must have initial conditions and boundary conditions. So the conditions that we mentioned can be classified into either initial or boundary condition depending on what variable are these conditions related to. So if the variables are related to time, so I say that at time 0 I know the concentration was whatever, or at time whatever I know concentration equal whatever. So it's a time related condition, then it is called an initial condition. If it's related to space, so if I say that at x equals 0 the concentration equals whatever, if at x equals L concentration equals 0, whatever the condition is, if it's related to space, then it's called a boundary condition. So if we apply this to the continuity equation, I'll take a simple form of the continuity equation, which is fixed second law, and we say that this is the equation, and I can expand this by expanding the del square term, and it's going to be like this. So if I want to know how many initial and boundary conditions I need based on the discussion that we have just gone through, then we can say that I have first order integral with or differential with respect to time, so I need one initial condition, and for each one of them I have three differentials, one for x, one for y, one for z. They're all space parameters, and I have second order for each, which means that I would need 6 boundary conditions. 3 multiplied by 2, 2 plus 2 plus 2, then will be 3 boundary conditions. So this is the information that I need to know so that I can solve the equation. Without the boundary conditions and initial conditions, I will never be able to solve the equation. And now comes the question: what is a boundary condition? How can I define it? How does it look like? What is the meaning of it mathematically? And this is going to be the topic of the next video, inshallah. So I'll see you then. Goodbye.